start the physics subject GRE. And okay, so I personally got 994 scores in physics GRE and in 2016. And you can I cannot guarantee that you will get the same score as me, but unless at least you can see how I solve the problem and how I attack this kind of GRE problem. I usually seldom do much calculation. I only try to guess the answer and try to find out which one is the best one. Okay, so at least you can follow my technique. I think you will have a good results. And I also highlight some important formula that you must remember. Okay, so the first one, the form what we are solving is the GR 9277. 9277, yes. Okay. Okay, so first one says that the wave function, you have a wave function ask about the momentum. So the first one is the standard quantum mechanics. By the way, at least you need to remember. Okay, so P for phi is basically you have h bar k phi because you will have additional ik. So this one, the answer is C. Second, the longest wavelength X-ray can undergo the Bragg is blah blah blah. Okay, with the space in D. Okay, so plot the graph. This distance is D, and then there is theta. Suppose there is a theta. And the white light difference, the white light travel difference is from here to here. So this is additional. So this is theta. So this 2 is plus 2d sine theta. So the maximum is 2d. The answer is D. And the third one, the ratio of energy of K characteristic X-ray of carbon to lose the magnetism. Okay, I don't know how to pronounce. It's most nearly. Okay, so important formula for the Bohr model. So Bohr model probably is the important one in the physics GRE because you will see various times. So basically, you need to remember some dependence of this En. So this Z means the number number of protons in the nuclear. So basically, if you know it will proportional to Z squared, and Z6 divided by Z12 is just 1/4 squared. So the answer is 1/4. Okay, so this you need to remember. And the unit is EV. Okay, so ask about the gravitational force. Okay, so this you also need to remember. For the uniform sphere with radius r, what the gravitational force is from 0 linear to r, and the quadratic decrease. And this one is I basically I should say the gravitational field is this one. Okay, and the analog is basically if you have a radius r uniform charge sphere, a solid sphere, then the electric field also is the same pattern, 1/r squared linear in r. These two you need to remember. Since once you know this point, then you can derive any point from it because you know it's linear. So these two you need to remember. Okay, this is the uniform charge solid ball, and this is the uniform sphere. Uniform solid sphere like Earth. Okay. So the first one is the Fr over F2r. This is proportional to the 1 over distance squared. So basically it's 1/2. Basically it's 1/1/1/2 squared. Okay, so the answer is C. Okay, and this one we already know is linear in R. linear knot. So what is the radius r over 2? So f r over 2 over fr is half. It's half. So what we ask is this one divided by this one. So it's twice. It's twice. The answer is C. The answer is C. And how you can derive this? Basically, you can use the Gauss law in the gravitational force. Gauss law in the gravitational force. Or probably you know, okay. Let me derive for you. Okay, so suppose you are R, and this R, and you can show that the gravity you at this point your gravitational force basically is controlled by this sphere. So all you need to know is the mass inside this sphere divided by so-called R squared. But m of r proportional to just the density times the volume of this sphere. So you have. So the answer is just proportional to r. Proportional to r. So that's it. That's it. Okay, and I think it's enough. I usually use 5 or 10. I usually saw 5 or 10 questions in one video, and I will see you guys in the next video.